Hello everyone, in this video we'll discuss about linked representation of stack. The linked representation of a stack commonly known as link stack. Link stack is the stack that is implemented using a singly linked list. The info field of the node hold the element of the stack and the link field hold pointer to the neighboring elements in the stack. The start pointer of a linked list behave like as a top pointer variable of the stack, and the null pointer of the last node in the list signal the bottom of the stack. This is the link representation of the stack. Next is operations on a link stack. There are two basic operations that can be performed on a link stack: push operation and pop operation. The push operation is used to insert an element into the stack. The new element is added at the topmost position of the stack. Now in this case, the topmost element is 1. This is a link stack after inserting a new node, that is 9. To insert an element with value 9, we first check if top is equal to null. If top is equal to null means there is no element in this stack. If this is the case, then we allocate the memory for a new node and store the value in its data part and null in its next part. The new node will then be called the top of the stack. If top is not equal to null, then we insert the new node at the beginning of the link stack and name this node as a top. This is a complete algorithm to push an element into a link stack. In step 1, memory is allocated for a new node. In step 2, the data part of the new node is initialized with the value to be inserted in the new node. Suppose we want to insert value 45. In the third step, we check if the new node is the first node of the linked list. This is done by checking if top is equal to null. In case the if statement evaluates to true, then null is stored in the next part of the node and the new node is called top of the stack. However, if the new node is not the first node in the list, then it is added before the first node of the list, that is the top node. Set new node next is equal to top and set top is equal to new node. This is a complete algorithm to insert an element in a link stack. Then pop operation. The pop operation is used to delete the topmost element from the stack. Before deleting the value, we must first check if top is equal to null, because if this is the case, then it means that the stack is empty and no more deletion can be done. If stack is already empty, then underflow message is to be printed onto the screen. In this link stack, if we want to delete a item 9 from this link stack, then topmost element is 1. In case top is not equal to null, then we will delete the node pointing by top and make top points to the second element of the link stack. If we want to delete this element, then top points to the second element of the link stack. This is the algorithm to delete an element from a link stack. In step 1, we first check for the underflow condition. If top is equal to null, that means stack is empty. Then print the message underflow and go to step 5. If this condition is evaluated to be false, then step 2 is to be executed. Set ptr is equal to top. PTR is a pointer that points to the top. Then step 3, top is made to point to the next node in the sequence. In step 4, free PTR. The memory occupied by PTR is given back to the free pool. Suppose we want to delete the element 10 from this linked stack. After deletion, top points to the second node in a linked stack. And memory occupied by 10 is given back to the free pool. This is all about the link representation of a stack.